right, people. All right. So, Pythagorean Theorem with right triangles where the sum of the legs, which in this case are A and B, the sum of not just the legs, but what's the magic? The squares. So the sum of those squares of the legs equals the square of the hypotenuse, the square right there. Okay? All right, so let's look at an example. So let's say we have a right triangle that looks like this. Whoa, boom, right triangle. And this is 5 centimeters, and this one's 12 centimeters. And I say use that Pythagorean theorem to find the length of the hypotenuse. Okay? So we know that the Pythagorean theorem are the legs squared, added together, is equal to the hypotenuse square. So we do know that one of the legs is 5. But if we square the 5, if we square it up, the area of that square would be 25. Plus, if we square the other leg, 12, we square it up, the area of that square, 12 squared, is 144. Now, if we added these both together, we should get the square of the hypotenuse if we were to make a square. So if we add those together, what are we at? We're at 169 is the square of the hypotenuse. But we don't want to know the square. We want to know what the actual length of the hypotenuse is. So you're going to have to think of what number times itself is going to equal that 169. So really, when we're solving an equation like this, c squared equals 169, to get rid of the square, we actually use the square root. If we take the square root of c squared, we'll just get c, and that's what we want. So we really, when we're trying to find what number times itself is 169, you're really taking the square root of 169. And it's actually going to be a whole number. Do you know that one off the top of your head? It is 13. So that hypotenuse is 13 centimeters in length. Now let's try one that's not as simple, okay? So again, this is going to be, well, let's just try it. So let's say here is my right triangle, and I give you, this is, let's say 4 inches, and this is 6 inches. And I want to know the length of this hypotenuse. And you're like, okay, this isn't so bad, Miss Everly. You just did one like this. Well, wait and see what happens. So here are our legs. If we find the sum of the squares of the legs, so the square of 6 would be 36. The square of 4 would be 16. That's supposed to be the square of the hypotenuse. So if we add these together, we're at 52 is the square of the hypotenuse. Now I run into an issue. And you might be like, well, what issue? I don't see an issue. Oh man, there's an issue. Because if I take the square root of 52, and I'm trying to think what number times itself gives me 52. Well, I know 7 times 7 is 49. That's a perfect square. And 8 times 8 is 64. So this is going to be a decimal. So my value for C, my hypotenuse, is not a whole number. And it's actually not even rational. So the book will ask you to round and make it into a rational number. You're going to approximate it with a rational number. And the book is nice. They have you round to the nearest tenth. So you know what? We practiced with approximating with irrational numbers. So we're going to go ahead and do that. So the square root of 52 to the nearest tenth. So we knew it was in between 49 and 64, the perfect squares. So we know it's going to be 7 point something. So to get that tenths place, we're going to go 49 to 64. What's that span? And is that 15? Span of 15. And then to get from 49 to 52, That's a span of 3. So I have the fraction 3/15. So 3 divided by 15 will tell me what tenths place to approximate to. So let's try. This one's nice. 15 goes into 30 perfectly. Twice. So we're going to go ahead and say that this is 7.2 approximately. And there we are. We actually approximated an irrational root to the nearest rational tenths place of 7.2. So that is my hypotenuse of that right triangle. Now I said that would be the last one, but I actually lied, because I haven't given you one that's a tad more difficult. Meaning, what if you have a right triangle and I say this is 9 centimeters, this is I don't know, and this is 15 centimeters. So we still have the Pythagorean theorem that the legs squared added together equals the hypotenuse squared. So I'm going to sub in. One of the legs squared is 9. So 9, if I square it, is 81. Now if I square the other leg, oh man, there's the issue. I don't know what that is. So I'm just going to keep it as b squared. And then the other one, I do know the hypotenuse squared. If I square 15, do you know that off the top of your head? It's 225. So now I am solving an equation here to figure out this value. So how do I get the b value isolated and alone? So how do I get this 81 to go away? All right, so I have 81 plus b squared equals 225. So here I go, solving an equation that you solved last year. I need to get this 81 to go bye-bye. So I'm going to add its opposite. I'm just going to subtract 81. And then it's gone. But if I do that to one side of the equation to keep it equal, I need to do it to the other side. So I'm going to get b squared to equal 225 minus 81, which if you subtract correctly is 144. And at this moment, you should be super duper happy with your teeth showing and eyebrows up and your eyes open, because this is perfect. I'm not going to have to approximate. This is a perfect root. So if I take the square root, the value of that missing leg is 12. And done. So thank you. Tomorrow in class we will be working with the Pythagorean theorem and applying it in real situations. See you then.